Kia ora. So with multivariate data, multi meaning many, we are going to measure more than one variable. And instead of surveying only somebody's height, for example, we might also measure their age, weight, and gender. To see what this looks like, let's begin with an example of multivariate data. Let's say we decide to investigate dogs. If we did a univariate study, uni meaning one, we'd only look at one variable. For example, how many dogs a household has. However, multivariate data has multiple outcome variables. A multivariate study might record, for example, the breed of the dog, color, age, and weight. So here are some results. And since we see there are multiple possible outcomes, we have some multivariate data. And multivariate data can provide us with lots of information, though we know what this information tells us. To analyze multivariate data, we first need to be able to display multivariate data. Graphs and plots are normally how we display this, so let's look at how we can compare them. Now, in the first part of this lesson, we looked at stem and leaf plots, dot plots, and box and whisker plots. Now, we have the data display skills. We can apply this in more meaningful ways by analyzing data and drawing conclusions. Back-to-back stem and leaf plots, multiple dot plots, and box and whisker plots are all useful displays for comparing two or more sets of data. Stem and leaf plots and dot plots are only useful for smaller sets of data, while box and whisker plots are excellent for larger data sets. Let's look at an example with back-to-back stem and leaf plots. So here we see the before and after weights of mountaineers after an expedition to Pakistan. What observations can be made? Well, there are many things we can learn from this plot. One is the number of people in the mountaineering. So these are the 8 people before the expedition, and then their weights afterwards. Okay, we can also see their before and after expedition weights and putting them in order. We could also see how much weight the members lost on average by looking at the means, and the difference between those is 6.125. So we could say on average, they lost an average of 6.125 kg each. Now let's have a look at multiple dot plots. Number of cats owned. What kind of observations can we make here? Well, we can see by counting, more people don't have a cat than don't have a Tyrannosaurus Rex. We can see 0 people had number of cats owned. 3 people owned 0 cats. 3 people owned 1 cat. 1 person, 2 cats. 1 person, 3. And we've also claimed that some people actually owned a Tyrannosaurus Rex. So, putting those numbers around, we can see from the data set that the median, or the one in the middle, tahirua torufa, 4 in each half, 1 is in the middle, tahirua torufa, and 3 is in the middle. So the median for cat ownership was 1, while for T-Rex, 3. We can also find our medians, interquartile range, by subtracting the upper quartile and the lower quartile. Last one, looking at box and whiskers, we can see comparisons can be made. For example, the median for the 88 was a little lower than the average for the 1989 margin of victory. We can see that this middle 50% is bigger than this middle 50%, so it's a bit more varied. This one a bit more consistent. Also, the 1988 season has a larger spread. The maximum minus the minimum is more spread out. Even though a lower maximum, the 1989 season had a higher median and a smaller range of upper and lower quartiles. We had mentioned that fact, that's more spread out. It's wider, that box. And we also could talk about the interquartile range being larger than the range of the margin of victory for the middle 50%, which is greater in 1989. Now it's time for you to try some Maori Mahi Maori Ora Ka Kite Anu.